Welcome to my kcse revision channel, Marita James, Greenwood Boys High School. Kindly subscribe, click the notification bell, you get notified once I upload a new video. Today we are looking at chemistry, kcse revision, and our topic today is the periodic table. So there are so many questions that are being tested on the periodic table. That is writing the formula of the compound, writing the electronic configuration of the elements, comparing the melting and the boiling points across the period, comparing the melting and the boiling points down the group, and also we have questions like testing on the ionization energy, structure and the bonding. You might be told using the dot and the cross diagram, show the bonding formed maybe between element Q and element P. Today, I will just want to make a few summaries on how to write the formula. So, number one, we look at writing the formula. So, there is here we have writing the formula. So, now we have writing the formula of the compound formed. Now, when asked now to write the formula of the compound formed, this is the technique that you are supposed to use. So you just come here, we have this is group 1, group 2, then this region here represents the transition elements. Then we come up to group 3, 4, 5, 6, 7, and 8. So what do? You just use the numerical numbers, you label this as 1, you use that number 1, you use this one as number 2, then we have this as 3, then we come to 4. After now writing this 4, you start now decreasing the number. Now from 4, you will come to 3, then you come to 2, then you have number 1. Don't go to 0 because the 0 will be representing the group 8 elements, which in this case do not react. Now suppose you have been asked now to write the formula of the compound formed. Write the formula of the compound formed between element H and element R. Between element H, so we have the first case we have element H and element R here in this case. So how do you write this formula? So you just come, if you are writing the formula of H and the formula of the compound formed between element H and element R, you just simply use these numbers I've indicated here. So we have number 1, number 2, number 3, number 4, number 3, 2, and 1. We do not have 0 because 0 represents the group 8 elements. So writing the formula of the compound formed between element H and element R, you just come and write this is H, then you will have R like that. Then how do you use these numbers now to have the formula? In this H, we have number 1 here. So this number 1 of H, we write at R. So we transform this number 1 here. Then you go to element R, down here we have number 3. Number 3 of R, we can bring it here, so we write like this one here. So simply that is the formula, whereby now you can write this one as H3R. Using the numbers, simply that is how you can write the formula. Suppose now you have told to write the formula of the compound formed between element P and element J. So we have our element P and element J. So how do you write this formula of that element? So I've said you just pick element P. So you write this one as this is element P, and then you will have J. Now you check this number. In P we have number 2. This number 2 we can took it to J. So we have P, it has a valence of 2 in short. Now we take this number 2, we write at J. So you will have that number here. So you write this number 2 of P, you write J to J. And this number J, which is also as 2 here, so you write these 2 becomes there. So we know that 2 and 2 can be simplified to 1. So the formula of this element of the compound formed between element P and K is just P, and then we have K. Suppose now you have been told to write the formula of the compound formed between element Q, and let's say we have another element here, and let's say we have this element K. So we have the formula formed between element Q and element K. How do you write that formula? So using these numbers, you just come and write. So we have this one as, this is Q, and of course you will have R. Then what will you do? We have this number on below here in this group 2, we have number 2 here. This number 2, you take it to K. So you can write it 2 there. And then you go to Q, you go to this Q. So then we go to K. This K, it has number 3 here. So you can bring that number 3 here. So simply the formula of this compound now we have as, this is Q3, then we have K2. Simply that is how you can write the formula. Suppose now you have been told to write the formula of the compound formed between element K and element W. So we can also have element K and W. So we have element K and element W. How do you write this one here? So you just come write your number. You just come and you have this element, not element K. We have I'm referring this element K here, not this one. So we can have this K. So you write this is K, and then you will have W. So K, it has number 1. So you can write number 1 here. W, it has also K as number 1. So this number 1 must be here. So we bring that number there. Then W, it has number 1 down here. We bring that 1 here. So the formula of this compound formed between this K and this W is K, then we have W. That is the simplest way of writing the formula of the compound. Suppose now also you have been told to write the formula of the compound formed between element Q and S. So we can have this one here, element Q, and then we have S. How can you write this one? So element Q and S, you can just write, we can have this is Q, and then you will have element S. Then this Q, it has number 2. So this Q with the number 2, this number 2 we write at S. So we can write this number 2 here. Then at where we have S, we have number 4. This number 4 we write at Q. When you simplify that one here, you will have that formula as Q 2, then we have S. That is the simplest way of writing the formula of the compound by using this number. So another thing we look here is writing the formula of the ion. So we have formula of the ion. We have the formula of the ion. So how can you write the formula of the ion? So formula of the ion. So writing the formula of the ion. Suppose now you have been told that write the formula of the ion formed by element K. Remember we don't have this K here. Write the formula of the ion formed by element K. When you look on this grid, I have labeled this number here. We have this is positive 1. You come to positive 2. Of course, we have the transition elements here. Then we have positive 3. We have negative or minus 4. Why? Because the group 4 elements, they can either gain an electron to be stable, or they can lose the 4 electron to be stable. That is why we have a negative or a positive. Then we have, this is a negative 3. we have negative 2, and of course we have negative 1. These numbers can represent the values of the element, and at the same time, we use these numbers to write the formula of the ion. Suppose now you have been told to write the formula of the ion formed by element J, this J here. Suppose now you have been told you write the formula of the ion, so we have the ion of, so we say the ion of, we have the ion of element J. How do you write this one here? You just come, pick this element J, so you can write this one here. You have this one as J. On top of it, on this J, it has negative 2. So you indicate this one here as negative 2, and that one simply becomes the formula of the ion of J. Suppose now you have also been told to write the formula of this element V, element U, V, and W. All of them, they have number 1, negative 1 at the top. So you can also be told to write the formula of element V, for example. The formula of element V, you just write, V, then what is the number we have at the top? We have negative 1. So you can have this one as negative 1. And that one now becomes the formula of the ion of that element V. Now we have those elements which forms ion by losing an electron. Remember this J, it is forming an ion by losing the 2 electrons. V, it is forming an ion by losing the 1 electron. And that is why normally they have a negative charge. Suppose now you have been told to write the formula, the formula of the ion formed of element Q. So we can have, for example, here the formula of the ion of element Q. The formula of the ion of element Q, you just write this one as Q. Then on top here, this Q, it has a positive 2. So you can write this one here as 2 positive. Why 2 positive? Because it is in a group 2 elements. When it is in a group 2 elements, it forms an ion by losing the 2 electrons. Suppose now we have to write the ion of the formula of the ion of element R. The formula of the ion of element R, how can you write this one here using those numbers? So you just come, write element R like this one here, and then the number we have here is positive 3 because it forms an ion by losing the 3 electrons. So you indicate this one here as 3 positive. That is how you can use these numbers we have at the top. At the same time, we have the mass balance of the elements, where we have positive 1, positive 2, positive 3, positive 4 minus 4, negative 3, negative 2, negative 1. Apart from indicating the valence of the element, you can also use them writing the formula of the ion. We can also look that how can you write the equation of the reaction? Some candidates or students sometimes confuse when they have been told to write the formula. Some write the equation of the reaction. When you have been told to write the equation of the reaction taking place, some write the formula. So that is the confusion we have. So let us look at when do you write the equation of the reaction. So we talk of the equations of the reaction. So we have the equations of the reaction. Suppose now you have been told to write the equation of a reaction between element Q and element J. So between element M and element J. Element M and the J. So let us look at this one here. We have element. We talk of element M and element J. We are writing the equation of the reaction. We normally use the formula. We are using these numbers 1, 2, 3, 4, 3, 2, 1 to write the formula first of the compound formed, and then we can be able now to write the equation of the reaction. So in this case now, you can have element M. You have this one as element M. This one is now combining with element J. Then you will have this one, they can form M, and then we have J. Now, using this one here, first write the correct formula. The correct formula of the product at M here we have number one. Number one we can take it to J. At this J here we have number two. So we can have our number two becomes there. So this is the correct formula of the product. And of course this one now will be now by a solution. So J, it is in a gas form, and then M, it is in a solid form. So you can use these numbers. You can use these numbers, number 1, 2, 3, like this one here, to have the formula first. Then from the formula, you will be able to write the equation of the reaction that normally takes place. And most students, they normally confuse when you have been told to write the formula, just write the formula. When you have been told to write the equation, just write the equation of the reaction with the correct formula, and then you will earn your marks. The other thing we look at is normally is what we call the chemical families. We have the chemical family names. We have chemical family names. We have chemical family names. Chemical family names on the periodic table. Chemical family names on the periodic table. What are these chemical family names? So elements in group 1. So we can also have the elements in group 1. All of the elements in group 1, they have been given the chemical family name of the alkali metals. So this one here I call the alkyls. So we have, these are the alkali metals. And why alkali metals here in this case? They dissolve in water. They dissolve in water to form an alkaline solution. Alkaline to form an alkaline solution. We have another group 2, so we can also have the group 2 elements. We have the group 2 elements. The family name is called the alkaline earth metal. So they are called the alkaline earth metal. Why call it the alkaline earth metals? One, they dissolve in water to form an alkaline solution. They dissolve in water to form an alkaline solution. Reason number 2, what they are called the alkaline earth metals, they are found on the earth's crust. They are found on the earth. Earth is crust. So in group 3, we don't have the family names. So we go to group 4. The group 4 elements are normally called the meteorites. So this one here I call it the meteorites. They are called the meteorites. This case here, these elements, they are meteorites. This is where we have, they are the same metals. They are the same metals. This is the group where we are getting an element like silicon. So group 5, we do not have the family name. Group 6 has no family name. So another family name is we go